Welcome! I'm Teresa Tarbuck, Assistant Professor of Chemistry. In this video, we will examine electrolytic cells, which cause a change in a chemical system by driving an electric current through the system. It is possible to construct a cell that does work on a chemical system by driving an electric current through the system. These cells are called electrolytic cells. Electrolytic cells are similar to voltaic cells in the sense that both require a way for charge to move in a complete circuit. Both have a cathode and an anode side, and both have a consistent flow of electrons from the anode to the cathode. Here's a simple electrolytic cell with an anode cathode or positive-negative electrode and a solution of potassium iodide in water that contains a small amount of phenolphthalein to visualize any changes in pH. Electrons are forced to move from the anode to the cathode. There are two possible anode oxidations, iodide ion going to I2 or water going to oxygen gas and hydrogen ions, an acidic solution. There are two possible cathode reactions, potassium ion going to potassium solid, or water forming hydrogen gas and hydroxide ions, or a basic solution. To demonstrate, how are we going to tell which reaction happened? We are either going to see the purple-brown I2 or oxygen bubbles in acid for the anode. For the cathode, we will see potassium solid forming, or hydrogen gas bubbles and pink tones from the basic solution. Because there is a purple at the anode, I2 is forming. This was the first anode reaction. The pink solution and bubbles, basic solution at the cathode, are water forming hydrogen gas and hydroxide ions. That was the second cathode reaction. Adding the oxidation and reduction half potentials, the overall reaction potential is negative 1.367 volts. This is an electrolytic cell. Thank you for joining me to learn about electrolytic cells. To learn more chemistry, look for our other educational videos on a variety of topics.